Тебя не слышно, если что.
Да, отлично. У Bluetooth аудио такой дурацкий глюк, что если им не пользоваться, ну, оно это в какой-то стендбай режим уходит, и пока несколько секунд не будет воспроизводиться аудио, я ничего не слышу.
Hey there.
Hi.
Let's wait for a few more minutes.
While we're waiting, I gotta tell you, it's absolutely wild how much having Nexus helps.
You're talking about our new CI?
Yeah.
Glad to hear that.
I don't remember when was the last time that the pipeline was all green the very first time.
I really like it. I also created pull requests to adding retries, but probably that will not be needed in this case.
Yeah, let's see. Yeah.
We probably need to request CNCF to give you access for managing our domain. Since you're
Because I need an API key. I don't know if it's Cloudflare or something else, but I need an API key so that certbot works and renews the TLS certificate.
All right, then I think we can start. So welcome everyone at Cozystack community meeting. I'll repeat that we have Telegram group where you can join and ask your questions. We also have Slack group in official Kubernetes Slack. We probably don't have any new members on this call, so we can go ahead and switch to agenda. So today I'm going to share that we prepared a new Cozystack release. We did a lot of changes according to resources. I think we're still working. Not all the packages still fixed to use new resources, new type of resources. But for now, you need to understand that we added additional parameter. It's called CPU allocation ratio. It's borrowed from KubeVirt configuration, and we extended it to all the applications we have. By default, in KubeVirt, it equals to 10. So it actually means how much CPU you can oversell. And we start filling the user requests from vCPU perspective. The real CPU will be divided to amount of these resources. For now, it's works slightly different, but I think we will align this logic in a while. We also switched to using Cozy PKG for deploying all the stuff in Cozystack to have the same logic for development and delivering the components. So our main script and all the make files updated to use this tool. For now, you don't need to install Fluxity, Helm, and Helm diff, YQ. So in one replacement, in one step, we replaced many dependencies. We also introduced Helm release reconciler for system components. That means if you change your config map, all the system components will also reread this config map and update their settings to this. And also a few changes in various things. I think I will not list all of them. There were also patch release, where we introduced a lot of changes to our pipeline. Now it looks really cool. And we are still working on making it more stable and replicated to external pull requests as well. So for now, it looks like, yeah, I'll show your pull request, Timothy. So we start testing all the applications in parallel. We added new tests for various type of applications, and now they're running every time when we create new pull requests. So now you can expect that we will break things not so often because we're starting to covering them by the tests, and we extended our test coverage. There were also articles about Cozy PKG and how we use it for Cozystack development. You might find it on the this link. The link is placed in the doc. I will put it into Zoom chat. I think I always forgot where is this chat located on it. Also, there were presentations about how Kubernetes and Kubernetes is work in Cozystack, how we organize the deployment of all the resources and make fully managed Kubernetes with Kamaji, KubeVirt, and Cluster API. That's all talk which was updated. You can find the link in the same page. And we started working with CNCF on organizing our own conference that will be virtual Cozystack Summit. For now, we scheduled it to December 3rd this year. So we expect that we will open CFP soon. That's actually it. And we have few things to discuss. So I started writing IDP bundle design. I put just few points. Maybe you just might comment on them if you think that you can, if you have something to say, actually. The idea of IDP is to provide a ready environment for developer for running their applications. And from my perspective, we need to provide it as two different independent parts. The part related to CI and part related to CD. The CI part should include the prepared templates of the repository where they can write their Docker files and define the dependencies for their application. Let's say you want to run some application. You say that your application needs to have a Postgres, Redis, and S3 bucket. You just define it a simple format in your repository. You write your application, and after you push it into GitHub or GitLab, it will also have pre-configured templates for GitHub workloads or GitLab CI, which will build Docker files somehow and Helm chart ready to install. And it also should have unified configuration for these dependencies rendered as Helm chart. The CD part means that we will add Argo CD to Cozystack because Argo CD is very useful tool for developers because they have the visibility and they can actually check the state of their deployment with the single union interface. And in Cozystack, we can create one new resource which called application. We can change this name later. For now, it's code name. So just imagine that you have another application in Cozystack where you can define your link to your repository, some access tokens for this, and some configuration to deployment. Let's say you can say that you want deploy from the master branch, or if you want to deploy from tags, according to some firmware policy. And settings for development previews. That's one of the requirements that anytime when you create pull requests in your GitHub or GitLab, it could actually spawn the new environments. So in Kubernetes application, we need to add option to pass through the secrets from the deployed applications in the same namespace into Kubernetes cluster. And when user will define this application, that will actually deploy all the dependencies they defined in their application, and also their application inside of this cluster, which will be configured to use the secrets. That's how I see that. Maybe you have other opinion. If you do, please share it.
Well, if I may, a lot of what you describe is more or less available natively in Argo CD, and the tougher bits may be integrating its capabilities with what we have specifically in Cozystack. So like Argo CD supports authentication in clusters, in EKS clusters in AWS with IAM roles. We need to probably implement something similar so it can authenticate with tenant Kubernetes clusters in Cozystack. But beyond that, I think a lot of the stuff you describe is already done for us.
That's actually it. We need to extend our OEDC configuration to use the single OEDC server for Argo CD, all the applications, and Grafana. The only thing that Argo CD covers just one thing is actually CD part. We need to make a proposal for design of how the users can actually simply deploy their applications in Cozystack to solve some questions like how they can actually pass through the secrets from the management cluster into tenant one, and also help them to prepare the standard pipeline for building, testing, and deploying this application.
That's a whole different story we really need a solution for managing secrets in general.
That makes sense. But it rises up a lot of questions, like where should be source of truth? We can integrate some kind of vault or integration with existing service providers thanks to ESO, but where the secrets should be stored initially. So for now, we just generate them automatically and store in management cluster. We can integrate some kind of replication of these secrets to the vault and download the secrets into from the tenant cluster. Or we can generate these secrets in the vault by default, and then download them into management cluster and tenant clusters as well. That might be better, but it will also bring a lot of work.
I don't think we should do that. In my opinion, you have to have some sort of solution to store secrets, and then we shouldn't force the decision whether to, to replicate them into a tenant cluster or to, I don't know, or will the user use a solution like external secrets operator or something like that? Because many people do not want to, actually have existing secrets. They use an operator to pull them from vault or whatever. This isn't really up to the platform to decide.
Yeah, the only thing I would like to mention here that it would be nice to have one default method and do not implement the others. So we just need to agree where is the source of truth. For now, it is management cluster. If we agree on that, then we can add additional plugins which will help people to synchronize the secrets.
Do you have any, Andrei, do you have any other chance where should be source of the truth?
It could be in HashiCorp Vault, for example, or we can integrate some kind of operator which will sync and create entities from the tenant cluster in management one and then report the secrets back.
But I see all these services should run in management cluster anyway.
Yeah, that's true. And I would like to not change the existing design too much. But there are other questions, actually. You need to have Argo CD to configure applications in management cluster, as well in tenant cluster, and also somehow to teach it to get secrets from the management cluster and pass it through into the tenant one. We had an example, how can we do that with FluxCD and Helm charts, but it looks more likely crunch for implementation. Maybe some kind of controller would help for that.
Once again, I would look at the external secrets operator. Now, personally, I really do not like the idea of using the management cluster as a store for secrets. I really think we should use specialized solutions like Vault. Yeah, but I'm quite sure that the external secrets operator can use Kubernetes as a source of secrets as well.
That's an interesting idea. And we can also implement the secrets where the user have access to the tenant clusters and to have this option enabled in Kubernetes application. I don't like using Vault as source of truth, but there is another interesting option. It's using KMS in Kubernetes configuration. So API server allows you to configure to store secrets encryption key in Vault, but you can still read it from the Kubernetes.
By the way, Andrei, what do you mean by the source of truth? Because I understand it's maybe things like I don't know, the password to access Postgres or something like that, a secret which is generated by the platform itself. Is that what you're talking about?
Yep.
But in general, public clouds, they have just a solution to store secrets, irrespective of what these secrets are about. Users can add these secrets to some sort of secret storage, and then later reuse them like in CI pipelines, or just look them up manually, or use them in applications that have the cloud provider library as a dependency. So, for instance, at a place I worked, okay, we were interacting with crypto exchanges, and of course we had lots of API keys for partnering with them. And yeah, we would store these API keys in Secrets Manager. These were absolutely not generated by AWS. These were secrets that we generated through other channels for our own use. I mean, not everything is part of the platform. At the end of, at some point, you just need a store for secrets. That's what I'm talking about.
Yeah, I understand what you're talking about, and I like this idea. This point is more about to implement the same design we have in public clouds. I would ask if anybody have experience with how is it done in OpenStack. And another question is when you're deploying managed service in AWS or Google Cloud, how do you get the secrets to accessing it?
I can give you an example with Postgres. The thing is that you, specifically with Postgres, you do not get a password handed to you by the platform. Instead, it's usually Terraform, and you just create a random string and use it as a password. And at the same time, you upload this random string to AWS Secrets Manager.
So yeah, I like this idea. So we should not generate secrets automatically. We need to expect that user will provide it. And we can implement this logic on the client. That might be a solution. And it can be easily integrated with any secrets manager.
That's the other problem. As if I'm not mistaken, Vault has the same licensing problems as, for instance, Terraform. I don't think it's a sufficiently open license for Cozystack, but at the same time, I'm not sure that there's a good alternative on the market at the moment.
I think that we can consume existing KMS system in Kubernetes and to wrap it into other additional API if we would need it. So it would allow you to integrate the secrets management with any secrets manager. It could be Vault or even AWS or Google Cloud if you like to use it. In our case, I really like idea for having everything accessible through the Kubernetes API.
I see. We'll have to work a bit on the design.
Yeah. For now, it's just initial thoughts. I think we will rework it a lot. Anyway, thanks for your ideas. One more question to discuss is Cozystack decomposition. We found that many people want to use just specific applications and don't use others. And also we have a problem that for now we're testing properly only pass full bundle. So the idea is to get rid of bundles as option and to provide options to select different values of storage, networking, actually the basic layer, and also to enable scope of applications. So the idea is to provide IaaS option, which will include virtual machine instance, disk, Kubernetes application, and TCP balancer. And pass bundle, which will enable Postgres, MySQL, Kafka, Redis, Rabbit, Nuts, FairyDB, and RabbitMQ. That will look like default Ubuntu repositories. We still need to have these applications in tree because we're running those tests as part of releasing pipeline. And we want to add the opportunity to defining your own application. So if you are admin in Kubernetes cluster, you can actually connect your own repository with your own applications. And this might have a totally different flow for development. It might have different releasing cycle. So that should be looking like this. Any thoughts about this?
Andrei, I do not see the persistent volume in Kubernetes. It will be part of the EIS.
Yeah, we're just talking about the applications you can see here. So if you install Cozystack without configuration, you will have empty catalog. That will also allow you to define your own custom applications without default set. If you enable pass bundle, if you enable EAS bundle, the new applications will be available, actually the same one, Kubernetes, virtual machine, on this virtual machine disk and instance, and TCP balancer. And if you use Kubernetes, you can order persistent volume claims, but you will order them from existing Kubernetes cluster. You don't have to see this as specific application from the on the Kubernetes on the Cozystack dashboard. Yeah, one more thing I forgot about is bucket, which can be used for both bundles. I think we can have it external or additional option like bundle. How to say it? Okay, let's say bucket or storage as a service. And for now, it might have just one application is bucket. Maybe in the future, we will add something like NFS storage and so on.
Bucket means some Minia or another S3 storage, right?
Yeah, for now we implement S3 storage on CVDFS. So this functionality is already implemented. For now, we're discussing about how better to split it to various set of configurations to let users choose what flavor of Cozystack they want to use, because some users want to have just EAS functionality. Some of them want to have plus functionality. Some of them want to have all of this. And existing system of the bundles, it works differently.
It need to split all the Cozystack for something switch for installing and split to ES, PS, storage as a service, etc., right?
I think we will have single installer, but in Cozystack configuration, you could choose what kind of services you want to provide. And that might be looking the following way. So we have, let's say, basic layer. Basic layer includes the networking options and storage options. For networking, we definitely need to provide the option of using Cilium, which we manage, and Cube OVN plus Cilium, because this stack is required for EAS functionality. Also, we need to provide storage. For now, the only option is LinStore. We need to provide also option none. as well here. To let users disable install and install their own storage. I think we also need to provide the option for CCM or external balancer. That could be MetaLB. Let's say Hasner Cloud or Cilium. That's what components I would like to support. So this is basic layer. Maybe in the future we could also provide the option for ingress. I don't know how to call it. It could be Jinx. Or how is it called? Ingress. Or gateway API.
You're talking about the default ingress controller.
Yeah. But that could be in the future. So for now, I think we don't need to implement this. And we need to provide the bundles option. Confused with the formatting. Which can be enabled simultaneously. When user installing the Cozystack, they could choose either they want Cilium or KubeOVM for Cilium with Cilium. They can choose the storage. They can choose default load balancer. And then they could also choose the bundles to installation. If they enable yes, they will have these services available in the catalog to install. If they enable this, they will have these services enabled in catalog, or they can do not enable everything, nothing of this. They can connect their own external repository and start providing their own services using Cozystack as a framework. All right, then. If you have no other ideas on this topic, let's switch to another one. I would discuss this one the first, because yeah, Timothy, would you like to introduce it?
You're referring to the idea of having load balancers and exposing services in general through a separate resource, right?
Yeah. I can explain just a little bit what we're talking about, then I will give your microphone. So for now, the only option to expose the services externally out of the cluster, we have this option external. By default, when you're deploying any application, any database, you can switch it to external true, and it will get public IP address and expose it to public network. I don't really like this option because it might be dangerous. Some applications running without encryption, and actually users can shoot into their leg. I think we need to provide more reliable way for this option, and that was input of Timothy. Give you, yeah, please go ahead.
Yeah, in fact, I would follow up with a concrete example that I was fixing just the other day. So the managed MariaDB If you create it as a single replica database, it creates a service named MySQL release name. However, if you create a database with several replicas, then it creates a service called MySQL release name primary, MySQL release name secondary. So basically the write replica and the read-only replicas. And so the fix I was doing, it turned out that the way we have everything set up, oh God, the way we have everything set up is that we create a service with type load balancer only for the primary service, the write replica, which does not exist if you create a single replica database. Furthermore, we don't expose the read-only endpoint. And if we were to say just naively change the type of service to load balancer as well for the read-only endpoint, they would be on a different IP address. They would consume 2 public IPs instead of 1, but with just 2 ports. And there's a lot of issues like that, which are individual for every kind of application. And we acknowledge that users, they might want to do something different. Maybe they want to expose the primary replica as they've been doing already. Maybe they want to have the right replicas, the right replica on one port, but the read-only replicas on another, but all on the same IP address. Maybe they were not anticipating that they're exposing their database to the entire world, and so on and so forth. And so my proposal is that, like the cloud providers do in general, is that we have a concept of endpoints for the managed services that are deployed in Cozystack, and then you can create load balancers, as you do, say, in the AWS, creates a resource called the network load balancer and point it at these endpoints. So we would stop having exposure on a public IP as an integral part of the managed service, and rather have this exposure as another service, as a load balancer with endpoints. Andrei, if you're talking, you're on mute.
Yeah, sorry for that. I would also consider to not use services abstraction at all, because in upstream there is thoughts to replacing it with gateway API. And as far as I know, gateway API also supports CNI abstraction, so you can expose the services using host name. And some gateway controllers actually supporting this. I guess Envoy and HA proxy should be supporting this as well.
Yeah.
I really like this idea of Cozystack tenants. So any application you deploy, it actually gets a reliable address in layer 7. So you can expect that this application will be available on this address, and it do not require you to have separate IP address for that. It would be nice to have such opportunity for the applications to expose them, not using API, not using IP address and service, and using something more smart like gateway or gateway API or some additional abstraction layer. Let's say it's the port. It can also proxy connections to databases, and also enable authentication using OEDC.
It's hard to think of a one-size-fits-all solution, but I was quite successful with using SNI as a basis for routing rather than when dealing, with arbitrary TCP protocols such as database-specific protocols, something that is not HTTP.
You have or you have not?
I have. I had this situation where I was in quite a closed down network with very few ports open. So to multiplex connections to different services across firewalls, when you're having just one IP address and one port open, I would install an HA proxy that would do an SSL pre-read, read the server name indication, and then depending on the server, route the requests to wherever necessary.
That sounds interesting. How many applications of which from the catalog we provide supports such configuration? Because
this was done absolutely external to the applications. What I would do on the client side, I would try to connect to the application, but I would use a forward proxy that would encrypt my connection and ask HA proxy on a specific domain name.
All right. So
and
you
then
use additional proxy protocol.
Yeah, sort of. I can go in a bit more detail later. I'll show you the code I used. I cannot demonstrate it right now.
That might be a solution, because as far I know, let's say if you want to join Kubernetes API, it can communicate only through the IP address. It do not support any CNI. If you have external load balancer or internal load balancer which routes all the requests through the HTTP to specific hostname, then it will work. But for some reason, the pure kubelet can't access Kubernetes API using CNI. As far as I know, some applications can support direct connection. Let's say Postgres client or MySQL client, and even maybe Redis client also supports accessing it through the CNI. So we can use HA proxy for traffic termination, and then it will route the traffic inside of the cluster.
Well, I can tell you that I was successful with using with connecting to MongoDB in this manner.
Yeah, MongoDB, I think itself have very specific protocol, not very specific. It's very similar to HTTP. Yeah, that looks like we need to get some research and to check if this functionality working for these applications, and then consider using some kind of gateway API for exposing them on predicted domain name. All right. Do you have 10 more minutes? I would like to discuss CPU allocation ratio.
Absolutely.
So the idea of this parameter right now that we unified the specification for resources for the end users. If they request creating virtual machine with 4 CPUs, the amount of requests will be divided by 10. Because KubeVirt have this parameter equals to 10 by default. We also extended this pattern to the other applications. So user can specify the amount of CPUs and memory size they want to, but sometimes we need to have oversell. So I noticed that for now we have this logic which we passing through the user requests into resources requests and add limits multiply it by 10. I think we need to change this logic to not multiply requests to get limits, but get limits and divide it by CPU allocation ratio and specify requests. The main point to this that
Andrei,
sometimes, yeah,
that is what we have already.
I just noticed that we don't divide, but we multiply the requests to get limits.
That must be some kind of error. I implemented it by putting whatever was provided as a number into the limits and then dividing that number by 10 or by the CPU allocation ratio to get the request.
All right then. If you design that this way, then I have no other questions. Seems if it's designed that way, but we implemented it different, then it seems we have a bug which we have to fix. All right, I will prepare, propose the change and provide it to you for the review. And also, I think to changing this default CPU allocation ratio from 10 to 4 or to at least 8.
This is this is configurable in our Cozy system, Cozystack config map.
Yeah, but I'm thinking about default option, which could be switched from 10 to 8. The reason to this change is how usually hosters do oversell. So here I would ask the community if anybody can share your experience, how much your limits are more than requests. No ideas. All right.
This is a tough call to make because what we really need is the input from people who actually do hosting, because they really do think about this and actually have to figure out how much they can oversell or not. Because otherwise, if I'm developing internally for an organization, I would not use limits at all for CPU, I mean. But when I'm hosting, I absolutely do have to limit my
Usage.
clients to limit abuse of my platform.
I have some experience from hosting company. When I was working for Vedas, his biggest Czech hosting company, we decided to divide any physical core by 3, and that was a compromise to their previous system where they were dividing it by 2. In new system we decided that we have more powerful CPUs and we will divide it by 3. But still, these numbers are very low in comparison to the defaults we're having right now.
I agree. In my opinion, it would be really good to implement, I don't know, some dashboards or whatever to actually measure how utilized the virtual machines, the pods, and so on and so forth are. So then,
you mean to show these values in vCPU?
No. I mean, give administrators of the platform a tool to understand how much CPU is being really used as compared to how much CPU is being requested, and then based on that
Requests
number
versus limits. Yeah, I think we had some dashboards for this. We need to research it.
Yeah, and then they can look at the actual usage compared to the requests, and then tune the CPU allocation ratio to to not introduce too much throttling, but to reflect the actual behavioral patterns of their users.
Yeah, that definitely makes sense. We need to find a way how to calculate the proper value and maybe write a short documentation about that. Maybe even just add it into our FAQ, like how to select proper CPU location radio.
Yeah.
All right then. Do we have any community questions? If not, going once, going twice. And thank you for attending Cozystack meeting. See you in 2 weeks.
Sorry.
Yep.
Can I? Sorry for my English. Can I ask about upgrading?
Sure. Feel free to do that.
So, yeah, I already did feature request on the GitHub regarding automatical updating of clients Kubernetes. Yeah, it's like the source from So it will be good for us. It will be nice if we can do a maintenance window with automatical upgrade. So how about it?
Yeah, I think this is really good input. So the idea that we can, we still not implemented the version choice for any application we have, but we will implement it soon. We have set of applications which we update in a releasing cycle. So I think anytime we will have latest version defined there, we can even set up dependabot for updating dependencies, for updating this version automatically. And every time when you get new release of Cozystack installed, we can also configure it to automatically update all the Kubernetes applications. And I really like this idea that you use negative numbers to specify, let's say, reviews from the latest, and it will always use the patch version.
Okay. So it will be like in 1 month, 2 months, maybe. If you.
For now, we have a release cycle when we're releasing new change version every 2 weeks. We trying to stick this development model. And we have now implemented the after updating for Cozystack platform itself. That should be easy to implement. The only thing we have worries that it might be not always working. In fact, Cozystack is just single YAML manifest file which have to be applied, and then it can deploy all the other components. The updating flow for the user applications is slightly different. So after you updated the platform itself, user can select their own application and update it manually. But if we'll implement the version choice, we can actually agree to do that automatically if you don't break any API changes. So anytime when you deploy a new platform, it will also go all over all the applications and also bump version where it's specified. I'm not sure if I answered your question, but that's really a good proposal. I think we will implement as part of version choice for any application.
Okay, thank you. Okay, I got it. Thank you.
Thank you too. All right then. I think we have to finish. So thank you for joining, and see you in 2 weeks. Bye.
Bye.
Bye, guys.